So we're going to start right on the top of lesson 31. Okay, so formula for the geometric series. You guys don't have to memorize this either. If you were taking a Regents exam, this would be right on your formula sheet. Do you remember this? The formula that goes S of n is equal to, and it's going to be a sub 1 minus a sub 1 times r raised to the n divided by 1 minus r. Okay, so that's the formula for the geometric series that we're going to use for example 1. So you are given an earnings of $33,000, and it says that it's going to increase 4% each year. So what do we do for increase again? Yep, 1 plus. So I'm going to go 1 plus 0.04. All right, write a geometric series formula S of n for her earnings over n years. So you're going to start right with that. So I have the sum of n number of years equal to, and I'm going to go a sub 1, which is the 33,000. And then I'm going to go minus 33,000. And my R value, I'm going to use what for? Yep, 1.04. Awesome. And then this is raised up to the n. And then this is divided by 1 minus 1.04. Okay, that's actually your first part of your answer because it just says formula and just a basic formula. So next, so use the formula to calculate the total earnings in the first 15 years of teaching to the nearest cent. So I'm going to do the sum of the first 15 years of her salary is equal to 33,000. Then I'm going to go minus 33,000. And then parentheses, 1.04 raised to the 15th power. And this is all divided by 1 minus 1.04. Okay. You may plug that entire thing into your calculator all at once. You guys remember how to do this? Yep. Excellent. Alpha y equals enter. So we're going to go alpha y equals enter. And I'm going to type in 33,000 minus 33,000 times 1.04. And this was raised to the 15th power. And then I'm going to divide this by 1 minus 1.04, enter. Everyone get that answer? Okay, so dollars and cents. So she earned $660,778.39. Don't want to forget the change, right? Someone's gonna have to read that back to me. There's no way I'm gonna remember that. It was. Thank you. Appreciate that. All right. What do you guys think? How's the first application? Not bad? Good. So I'm going to skip down to, I said, number 3. Okay. So a parent would like to open a savings account to save up money for their children's college education. They place an initial deposit of $12,000 into an account. This is going to be your P value in your formula, which has an annual interest rate of 5.6%. So again, we're going to go 0.056, sorry, is equal to your R, and is compounded monthly. Okay, it's been a couple days. What does compounded monthly means? We use, yep, very good. So n equals 12. how long will it take them to save up $40,000? Wouldn't you agree that this is something you could really calculate if you wanted to? Yeah, absolutely. If you're saving for a car or something, you have money invested. It's a nice application. This is a formula. This is the second financial formula that's from your notes. So this is all the way from lesson 28 when we did all of those. And this is your formula that goes P and then 1 plus R divided by N raised to the N times T. Now you're just going to sub in. So what do we know here? Well, we want them to make $40,000. So where's 40,000 going to go? Yeah, on the left side. So 40,000 is equal to, our principal investment was $12,000. And I'm going to go parentheses 1 plus 0.056 divided by 12 raised to the 12 times T, because that's unknown. Okay, so let's start kind of chipping away at this a little bit. So it might be helpful to get that middle number, right? So what is 1 plus alpha, what equals, enter, 0.056 divided by 12. So I have 40,000 equal to 12,000. Did you guys get like 1.004? 1, 2, I'm gonna just do a couple of these. 1, 2, and 7, raised to the 12t. Okay, so what needs to happen next? Perfect, divide out the 12,000. I just need to check and make sure that this is screen sharing, which I feel like it might not be. Okay, so you're gonna divide your 12,000. So divide by the 12,000, and to keep this really accurate, you don't really want to type anything in yet, unless, does this work out nice by chance? No, okay, I didn't think so. Most of these really don't. I mean, just say you don't have to do a ton of writing. Couldn't you cross off your zeros? You know, you could do things like this. Those are gone. Then at least you're writing a little bit less. Oh, does it? Okay, that's better, right? So 10 over 3. Good. Equal to 1.0046667 raised to the 12 times t. And now what you are left to do is solve this. And obviously we want to get t. So what can we do here? How do you get that power down? Yeah, you could pull it down in front, or you could do a log. Yeah, let's do a log. So I'm going to do power down in front, log of both sides. That works. Or again, you can convert it to log form too. So I'm going to do this. So I'm going to take the log of the 10/3. And that is equal to power down in front. And then that would give me the log of 1.004667. And now you've done the hard work. So you can finish from here. The log of this decimal is just a value. So I'm going to divide that over. So I'm going to divide by the log of 1.004667. And then this is going to be equivalent to 12 times t. So divide by the log of 1.004667. And at this point, if you want to type that in, that's okay, because you're almost done. So what do we get here? The log of 10/3 divided by the log of 1.004667 4667. I got like 258.5773 equal to 12 times t. All right, so what's our last step now? Yep, perfect. Divide by 12. Divide by 12. So how long is it going to take them to save the 40,000? So divide by 12. I don't know, like 21.5 years? Is that what you guys got too? Yeah, somewhere in that vicinity. So 21.5, and I believe this was in, I'm looking. Was it months? Well, even though you're compounding monthly, your answer is not in terms of months. Yep, so this is still going to be times in years. Yep. Yes. I mean, that'd be a really nice stuff, but there's no way you can save that kind of money with that small interest rate, you know, in a year and a half. But it's a nice thought. So 21.5 years. All right, how do you guys feel on something like that? Okay, so next problem. Over to number 4, and I'm going to go really slow through this, okay? So, at some point in your life, you are going to own a house, most likely, right? Okay. So this formula right here represents one version of a monthly mortgage payment formula, because there are other different versions here as well. Yes, this was given on a Regents before. And yes, everything that's listed at the top there would be provided for you. You don't have to memorize this. In addition, where all these variables are stated, this is always given to you, okay? Don't panic. So these are always given. So the capital M stands for your monthly payments. You pay a mortgage every single month. P is the amount that you're going to borrow from the bank. R is your annual interest rate, and M is your number of monthly payments. So to begin, since the bank's family would like to borrow $120,000 to purchase a home. So what letter is that? Yep, very good. I'm going to do this. I'm going to write it just right next to it. They qualified for an annual interest rate of 4.8%. So just like you're used to doing, you got to move your decimal 2 places, 0.048. Algebraically, determine the fewest number of whole years that the bank's family would need to include in their mortgage agreement in order to have a monthly payment of no more than $720. So we're shooting for this goal. And once again, this is something you could really sit down and do with a budget, you know, like after you graduate from college and be like, yep, I want to buy a house, but this is what I can afford and this is what the bank would give me as an interest rate. All right, so we're going to solve this out nice and slow. So we want to figure out what type of mortgage they need to take out. You know, if it's going to be 15 or 30 year, or maybe something in between. The 15 and the 30 years are the most common. So I want capital M equal to. So I'm going to go 720 equals. And I'm going to go really slow because this gets very complicated. When you make math and you know your real world applications, it does get complicated. So I have P. I am borrowing $120,000, and I'm going to go times. What was it? R over. So 0.048 divided by, was it over 12? Thank you, I appreciate that. I wish I could have both up at the same time. And then next fraction here, we're gonna go 1 plus that. So 1 plus 0.048 divided by 12. And then this is going to be raised to the n, which we don't know. And then this gets divided by Same thing, raised to the n minus 1. So this is going to be 1 plus 0.048 divided by 12 raised to the n minus 1. All right, looks like a mess, doesn't it? Yeah, let's get some of these numbers, okay, guys, so we can consolidate this a little bit. Couldn't I type this times this right now? Let's do it. So 720 equals. So 120,000, just go real slow. And this is times 0.048 divided by 12. I got 480. That's nice. I'm going to keep typing. I'm going to get this now. What is 1 plus 0.048 divided by 12? So this is 1.004 raised to the n, which means, isn't that the same thing? So this is going to be 1.004 raised to the n minus 1. All right, how's that so far? Good. Now, what's advisable next is to actually take it and cross multiply. So let's take the 720 times that, but I'm really not going to actually do it. So I'm going to show 720, and then we're going to go 1.004 to the n minus 1 equal to 480 times 1.004 raised to the n. Everyone feeling good still? Which side's more complicated, the left or the right? The left. Yep. So for that reasoning, I am going to divide the 720 to the other side to get rid of it because I want to make that side easier. Again, it's not the only way to do it, but that is my advice. Let's get rid of that. Now, use your calculator. What's 480 over 720? I think this simplifies a bit. Is it 2/3? Thank you. So this is equal to 2/3. And then I have times to the n. Okay. So next, and this is where this gets a little bit tricky and you want to make smart moves to kind of help yourself out a little bit. Now, what you're going to notice is the left side and the right side, they kind of look similar here. They both have a 1.004 to the n, which means I want to get those together. So what I'm going to do is I'm going to actually add the 1 over here, and I'm going to move this term over here. Okay, I'm going to flip them. So I would have 1.004 to the n minus the 2/3. Yep. Yep. No, you're okay. These aren't supposed to be easy questions. Equal to 1. Yep, these are designed to make you think a bit. So now from here, what I can do is I can take out a GCF. I promise it's going to get better in a second. Okay, so I'm going to do a GCF. My GCF is 1.004 to the n. How do I make this the same? I multiply it by 1. How do I get the 2/3? Just like this. Equal to 1. Again, we're getting there. We're getting really close. What is 1 minus 2/3? Yes. So I have 1.004 to the n times 1/3 is equal to 1. Can't I divide 1/3 over? And what's 1 divided by 1/3? Keep change flip. 3. So I get 1.004 to the n equal to 3. Now you can breathe a bit. Now you've done the hard stuff. Now, just like the last question we did with the financial application, can't we do powered on and front log of both sides? Absolutely. So now you're going to go n log 1.004 is equal to the log of 3. And then what do I do next? Can't I divide? So I'm going to divide by the log of 1.004. So I'm going to divide by the log of 1.004. And what is n equal to? And then I got to go back and read the question and see if we're done. 275. Yep, go ahead, guys. 0.202. Okay. Now, what does n mean in the context of the question? Months. Huh? Now, when you go to the bank and you tell them that you would like to take out a mortgage, they are not going to write it for a number of months. They're going to write it for a number of years. And you pay it every month. So I need to divide this now by, yep. So we need to take out a mortgage for how long? 23 years? Okay. Yeah, which you can't really do. They're probably going to tell you got to do 30 years, but that's okay. So this would work out to be a 23-year mortgage. Yeah, standard terms for mortgages. I don't know how much you guys know about this because why would you? You don't own a house yet. But mortgages, you can do a 10-year, you can do a 15, you can do a 20-year, you can do a 30-year. Usually they don't really offer things like this, so they would probably tell you to save up more money. So you could reduce this down to like a 20-year or to have a lower monthly payment and have a 30-year instead. Okay, how's this one? Okay, again, none of these problems are supposed to be easy, but they're supposed to show you nice applications of what you've been learning. So the next one is a chemistry question, we'll say. You guys talk about titanium-44. What about cobalt, what is it? Cobalt 12? The one that does the half-lives? Yep. So a lot of your chemical elements are going to behave like this. So you're given that titanium-44 is a radioactive isotope such that every 63 years, I'm going to stop. We did this yesterday. What does this mean I do in my exponent? Perfect. P divided by 63. Its mass decreases by half. What do I use? Yep, 0.5. And technically decrease means I would be doing 1 minus 0.5. For a sample of titanium-44 with an initial mass of 100 grams, write a function that will give the mass of the sample remaining after any time. All right, so let's stop, write the function. Titanium, I'm going to do T of T just so it looks kind of like titanium. So T of T is equal to, I have 100 grams initially, and 1 minus 0.5 is 0.5, and this is raised to the T divided by 63. So there's your equation. And it says predict what you're going to be between year 0 and 10. So predict, and then we'll do the actual here too. So we're going to do year 0 first. So we're going to do t of 0, which, I mean, you don't really have to show this if you know the shortcut. So 0.5, and then this is 0 to the 63rd. And anything to the 0 is 1, and 100 times 1 is equal to 100. That's your first value. Now we need to find after 10 years. Looking for a time. So t of 10 is equal to, this one you're going to have to put in your calculators. What is 100 times 0.5 raised to the 10 divided by 63? 89.5813. Thank you. And then what you're going to do is it says to find the rate of change. Rate of change is just like slope. Change in y over change in x. I'm going to do rate of change. That's my abbreviation for you. So I'm going to go 89.5813 minus 100 divided by 10 minus 0. And what do we get from this one? So I have 89.5813 minus 100 divided by 10. All right, so my rate here would be negative 1.4187. Okay, so now we're going to use this to predict the amount of titanium after 40 years. So I started with 100 grams, and then my rate was minus 1.04187 multiplied by 40 years. All right, so what do we get? So that number and times 40. How much is left? Yep, 58.3 grams. Now this is your predicted model, because this is judging by that equation right there. This is what we would call predicted. So now that part's done. So now part B here last. Sorry. Is the actual mass of the sample or the estimated or predicted one greater after 40 years? So now you're going to compare this one to the one from the equation. So the one from the equation is here. So now I'm going to go T of 40 is equal to, and we're going to go 100 and 0.5 raised to the 40 divided by 63. All right, this is going to give you a different answer, but what is it? 64.39. Thank you. So we'll call it 4 since it's the same as the other, I guess. So which one was greater, our actual or our predicted? I think our actual, yep. So your actual is going to be your greater mass. Okay. How do we feel with that application? And again, there's a lot of these that you would see. Cobalt and carbon are examples too that do, you know, your half-life properties from science. So we tend to try to make them, you know, relevant to what you're kind of learning in school anyways. Those are good for now? Okay, I'm going to change gears and just start this next review sheet, and then we'll finish these up next week. I like to let you see how, again, all that math you've been learning, you know, can relate to these scenarios. So I like to give you a ton of these. All right. So let's do number 1. So I gave you this sheet yesterday, correct? Okay. So I'm going to change gears to this, and then when you return next week, we'll definitely finish these. Okay. So in the future, do any of you plan on buying a car? I would hope so, right? Okay. So you are going to receive $2,000 as a graduation gift that you plan to use towards the down payment on a car. The car that you are hoping to purchase has a sticker price of $24,000. And using the formula below, determine the monthly payment to the nearest cent if you take out a 5-year car loan with a monthly percentage rate of 0.425. So does anyone know what a reasonable car payment is per month? Do you guys have any idea? That's okay. I mean, why would you, right? So your car payment should obviously be smaller than your mortgage payment. Like usual, typical Americans, if they have a car payment, like maybe on the low end would be like $300 a month, maybe on the high end, $500 or $600 a month. It's all impacted by, I'm sure you've heard mention of like your credit score and how well you're doing overall and what kind of percentage rate they give you. Okay. So this is another formula, kind of like the mortgage one, but way easier. And everything that's listed on the side there was given to you. Okay. So let's start writing out these values. P of N is the amount that you borrow. So how does this work? Your car costs $24,000 and you're going to put down $2,000. So how much do you finance? Exactly, only $22,000. So your amount that you borrow is the purchase price of the car minus the down payment. I've actually found in the past that a lot of students don't realize that. So yes, that gets deducted from what you're going to finance. You don't want to pay interest on money you already have. N is the number of monthly pay periods. How long is this loan? Yep, 5 years. And how many times do you pay it each year? 12. So 5 times 12 is how many payments are you going to make? 60. Yep. And 5 years on a car loan is usually the longest you would want to take it out for, because you would become upside down on your loan, as in you would owe more than the car is worth, because cars lose value. PMT stands for your monthly payment. And again, that's just like one variable. Do we know that? We don't know that. But, and then your interest rate per month, I'm going to move the decimal 2 places. 0.00425. All right, we would like to calculate what your monthly payment would be and if you can afford this car or not. So the amount that I borrow is $22,000. Equal to, PMT is unknown. If that bothers you, you could just really write it as an X if you prefer. It's up to you. So PMT, and then I'm going to go big fraction. I'm going to go 1 minus, and then I'm going to go 1 plus. And in this case, that little I represents 0.00425. And this is raised up to the negative n, which is negative 60, divided by, looking for an I, which is 0.00425. And close up your parentheses. Would you guys agree the parentheses, that's all something that you know that you could type in? Yeah, so this just goes right in the calculator, actually. Right in your calculator. Just be careful with it. Obviously, I'm giving you some pretty complicated formulas. All right, so I have 1 minus 1 plus 0.00425 raised to the negative 60. Divided by 0.00425 for an answer of $22,000 52,000 equal to P on T or X, whatever you prefer, times, you guys get like 52.86. So 52.8623. Did you find it? Your mistake?
Yeah.
Good. Yep, it happens. It's complicating your typing a lot. So now to finish this, actually, all I have to do is one thing. You guys see it? Exactly, divide by the 52. Perfect. No logs involved in this one. So I'm going to divide by the 52.8623. I'm going to divide by the 52.8623. And what does this person's monthly car payment work out to be? Thank you. $416.18. Yeah, and that's a reasonable payment as well. You know, like it's in a vicinity that it's possible. You want to make sure when you do questions like this that they are, you know, reasonable. Like you can't tell us that you have a negative car payment and, you know, unless you're just really, really wealthy, this is not going to be like $20,000 a month, okay? So $416 and then $18. But I think I'm going to stop there for now, and we will do the rest of these when we return next week. But let's make sure that you know what you are responsible for instead. So bring this sheet back with you next week, and same thing with that sheet that says test on it as well, please. Because I like doing these and going nice and slow through them, so I want you to have a chance to do more with that. So where did my agenda go? Not there. So assignments for the week. Is that in there? Here we go. All right, so you need to please accomplish problem sets 29 and 30 in your packet. Those I will check when you return to class next Monday, so you don't need to submit anything on those. Anything that bothers you too, just make sure you're circling, because we can definitely talk about it on Monday. And then your other two assignments, you have applications on Delta Math. So you have assignment 35 and you have assignment 36. No quiz this week though, okay? So I want you to just take care of those problems. And I'll caution you too on the Delta ones, please be careful of your rounding. If you find you're getting answers wrong, it's going to be because you rounded too much during the question. Okay, so use your calculator and keep hitting the up arrow instead, just so that you can kind of avoid any of those pitfalls. Questions, guys? Okay, because you guys are not here tomorrow. My other guys are here tomorrow. You are here next Wednesday. Okay, and we'll finish up these applications next Monday, and then we're going to move on to probability and statistics. So something different, no more logs. All right, you can take your last 10 minutes. You can get started on anything you would like to. Toolbar, move out of the way.